Harsha is a security engineer and researcher specializing in cloud native application platform protection. He's passionate about securing digital systems and tackling emerging cyber threats at large scales. So today he'll be presenting the Deceptive Shield, Unmasking allowPrivilegeEscalation falls in Kubernetes security. So yeah, the stage is yours, Harsha.
Hey all. Yep. Myself Harsha. I work for Palo Alto Networks. I will be talking about unmasking allow privilege escalation in Kubernetes security. How many of you have worked on Kubernetes? A show of hands. Okay. So yeah, who am I? I was a security engineer before. I have transitioned into product management. I was leading infrastructure security at Hotstar, and right now I have joined Palo Alto Networks, and I'm a product manager here and a security researcher. So yeah, so basically, what is security context in k8s? Before getting into the details of allow privilege escalation, basically there's something called a security context in Kubernetes, if you guys are already aware, which will let somebody define what are the security policies or controls for a pod for any object in Kubernetes. So in security context, like these are examples of what you can define. Think of run as user. Can you run as root? Can you run the pod as root or not? And can you allow privilege escalation inside the pod of any kind? Let's say you mounting host volumes, you sharing the host process, host network, and all that stuff, and you enabling SecConf profile, app armor profile, and all that stuff. And most importantly, capabilities. What are the capabilities it can have? What kind of system calls can the pod made? Can the pod make? These are all defined in security context in k8s, right? And we have one problem with allow privilege escalation here. And what is the problem? Kubernetes source code claims that allow privilege escalation, as the name suggests, that hey, once you enable this, once you set this to false, will ensure that there's no privilege escalation from the pod to host or any kind of gaining more privileges and stuff, right? But that's not true. What is the general expectation from this control? Once we set this to false, we have, it is taken to granted that this pod is completely secure from privilege escalation. It's often seen as a silver bullet, and every CSPM, KSPM, all the tools see this as, hey, once this is set to false, there's no privilege escalation possible anymore, right? But what is the reality? This this flag only sets no new privs. This is a Linux control, a bit set a flag. Once you set this flag to 1, it can be 0 or 1. Once you set this to 1, it ensures that there are no new privileges gained, right? It's not that it will not, let's say if there's sys module, network admin, socket admin, if these capabilities are already there, it will not prevent you from escalating your privileges. And what is the capability confusion? So Kubernetes source code claims that if you do allow privilege escalation false, you cannot add caps sysadmin. So if you add caps sysadmin, you are basically, root of the entire kernel, think of it, right? So, but yeah, it does allow capsys module, which allows you to load dangerous kernel modules, which is indirectly privilege escalation by its nature. And network admin, you can change all the network config of the entire cluster, right? Let's say you can bring down a whole cluster of prod, and cap net raw, you can open any raw sockets. Let's say your main application is listening on some port, you can bring it down, you can change it to a different port. So the whole point is allow privilege escalation being false and blocking sysadmin is just not enough, right? So basically, this is the code where there's a test container, a test pod, where you set allow privilege escalation being false, and you add these capabilities, which in itself is like a privilege escalation. Kubernetes does allow this, okay? And there's more to it. Basically, Kubernetes claims, I'll show you the source code, that like I told, once allow privilege escalation is false, we also block adding caps as admin, right? But there's a loophole in this. If you basically, if you write caps sys underscore admin, it does block it, yes. But if you just do sys underscore admin, The container runtime interface maps both of these to sysadmin capability, but Kubernetes code, source code, does not validate this. You end up getting a system admin given your allow privilege escalation is being false. So the whole point is all your compliance scanners, ESPM tools say that, hey, there's no privilege escalation possible in the cluster because I've enabled this flag, but it's not true because you add sysadmin and you're there. So yeah, for example, the first code, this block gets blocked because you're doing cap underscore sys underscore admin. But if you just do sys underscore admin, you're there. What's the real world impact? Like I told, security scanners show you are compliant because the flag is set, and CISO thinks, security engineer thinks, hey, escalation is it's prevented. There's no escalation, and actual privileges can still be abused. The goal of privilege escalation of an attacker is still possible, right? It's just like this guy doing security checks. And compliant requirements say that, hey, you're all compliant, you get your PCI, SOC, GDPR, everything, but there's no security. There's only certification rate. So let me show you the source code. So yeah, if you look at line 7700, this is Kubernetes source code. So basically what it does, whenever you do add this capability, caps admin, it ensures that cannot set allow privilege escalation to false. At the same time, when this is set to false, you can't add caps admin, right? This is what Kubernetes source code does, right? That's not the case. So yeah, then how do you actually secure your pods? Because Kubernetes source code controls itself are failing. You should drop all capabilities by default if you're not sure what capabilities the container is bringing by itself. And then use admission controller, OPA, Gatekeeper, Kaiwano, or even CEL based validations work. Just ensure that if there's allow privilege escalation is false, you ensure that there's no capabilities added explicitly, right? And explicitly control capabilities, that's what I was talking about. And you can use SecConf and AppArmor profiles. You'll have a good visibility of what process calls are being made. Even if a pod is privileged, you will have a good control on what can be blocked and what can't be, right? So this is the issue I did submit to Kubernetes. So basically, the bottom line is that they acknowledge that this behavior is confusing, and fixing it is not straightforward because of the backward compatibility issues. And this issue is like still open. I mean, there's no, we don't know what they'll do about it. But yeah. Uh, so this is it about the allow privilege escalation deception in Kubernetes.